So in this video, we are majorly going to talk about different types of web authentication mechanisms. There are, lots of authentication mechanisms through which you can gain access to an external computer or any external server. But here we will be, specifically focusing on web-based authentication and of course HTTPS protocols. And yeah, I mean, you might be wondering like how do I implement authentication for my next application and whatever you are building. So in that case, this video is definitely going to help you. We will look into cookie memory-based session authentications. I will be briefing about that, and then we will look into JWT Auth, which is the major player, I would say a game changer in authentication world, because we will be comparing both of them, and it can be the case where we have cookie-based authentication better than JWT in some specific use cases, but I haven't found any. And I feel that JWT Auth is much safer, but you can do all kind of temporary stuff, and of course cookie sessions can also be implemented that way, but it adds I would say more ease while performing these things. And then we will be looking into different mechanisms like basic authentication, bearer authentication, and then we have oAuth, which is built up over it. It's basically, it follows the concept of JWT only, but it has some other things like you have to go as a client to a specific website which supports this oAuth and then generate your authentication tokens and so on. So let's walk step by step. First, let's try to understand cookie memory based session authentications. So if you see this diagram, here we have our backend. Let's say we have some front-end server which asks for email and password, and whenever a client enters it, the backend will go and check into database. Okay, john@email.com, does this exist? And let's say database says yeah, the data exists. John@email.com is existing in the server. Then it will look into the password and check if the password is mapping well with the existing password or not. And of course these passwords are secured, stored in a very secure way, like hashing, salting, which is a different thing altogether. But you should know that they are not straightly stored like John and then ABCD, because and there can be servers, it's of course their choice, but this is a very insecure way, because let's say at any point of time your database gets exposed for any reason, then all these passwords will pose as a security threat. And of course even if it doesn't get exposed to the public, it can definitely affect let's say internally, if it gets circulated, that is also kind of a security threat. So now what happens is, whenever John wants to log into the backend service, they will provide their credentials with the password and send it to the backend. The backend will look into the, let's not have this active cookie sessions for now, let's have identity database. Okay, and we don't need sessions also. So the backend, what it will do is it will look into the database, it will find that this email exists. If it exists, it will look for the password, and if both of those match, it will generate a session cookie for the user. Okay, so for the simplicity sake, let's take a gibberish string. So this is generated by the browser, and this will be returned in the response to the user that you have been successfully logged in, and this is your session cookie. Okay, so like this. Okay, from now onwards, any request, let's say this is a banking application or a UPI application. UPI is like a digital transaction system in India for making any kind of purchases and all, and it is very much used like literally everywhere. So let's say we have a UPI backend here. We have something called get balance to check the balance. Then we have withdraw or transfer. Basically, let's keep it simple. Let's have get balance and transfer. But we have n number of applications, right? So yeah. So the way it works is, now for every next request, let's say John wants to see his balance, so he have to make this call to get balance. With this session cookie, it can be stored in header, it can be stored in body, preferably in header. It will pass this cookie, and the browser, what it will do is, so let's move on from identity database and let's make it active sessions database. So browser will store all the active sessions here. So for the John, let's say it stored the session cookie with let's say duration of 60 minutes. I think that is more than enough.
Okay. Now, when the John requests the data, the browser, it will look into the database and see, okay, this session exists or not. If it exists, then it will see it is not expired, and it will also validate email and do all kind of validation stuff. Okay. Once the validation is done and everything is fine, then the browser will perform the operation of the get balance and return the response to the John to John. Okay. And for transfer as well, it will do the same thing unless it requires some additional kind of authentication. Okay. So you can see that whenever any new request comes in which requires authorized access, it must have this session cookie. Okay. Otherwise the server will very likely return a 401 response, unauthorized response. Okay. Now this looks clean and this looks very secure as well, but if you carefully notice, there is a very small loophole into this. Okay. If you are able to identify that, that is great, but if you're not, then let me help you out. So it's not just single John, right? It is n number of Johns, n number of Manish, and so on, right? Now let's say if we have like if I tell you a typical application would have lakhs of users, but let's say for simplicity we have 50,000 of use active sessions. Okay. So let's say we have something like this, multiple sessions and so on. Okay. And for every operation that is happening, let's say there is a request from Manish, the backend is again going to see to look have a lookup into this active session database. Okay. Now, depending upon how this active session database has been designed, what kind of data structure it follows, like let's say if we have something called a normal list, or I mean, yeah, normal. Let's take an example. Let's make it very simple. So let's say we have a normal list where all these active sessions get appended. So let's say Manish has a session ID of 7. So for that, the lookup operation would be O of 1, because it has to iterate through each of these elements, reach the seventh one, and then validate, okay, this session exists. So you can see that this is O of n time complexity. And let's say in single second we get how many? 20,000 requests. So for all those 20,000s, we have O of n operation, which is going to be a lot of load on the resources, right? And let's say if someone is even one step smarter, they have something called a hash map where the lookups are O of 1. So we might have database something like this. Mm, okay, and so on. All right. And please don't get confused if you are not familiar with these kind of data structures. Basically, the thing is whenever you store something in list and when you do a lookup operation, you iterate from the first element and go till the end to determine if they exist or not. And depending upon what kind of list it is, if it is sorted list, then it could be faster with a binary search and all that kind of thing. But that is a different topic. And when you have something like hash map, you just check if the key exists. So let's say one exists and it goes O of 1. So now you must be thinking our problem is solved if we use something like, and most of the active sessions database, this is definitely using, a hash map kind of structure. But here's another problem. Even if you go with a hash map, you got a time complexity of O of 1, but you missed out in the space complexity, because space complexity for any of these cases is still going to be O of n, meaning that every session cookie must be stored, right? There is no other way to determine if the session exists or not. You have to store it. And for that, space complexity is O of n. And depending upon n number of sessions, like not just for this, let's say there is specific sessions for other kind of operations which are minor operations, you will have a different database for that, and it will add up to a lot of complexity also, right? You have to make sure you are looking into the right session database and so on. So again, you were smart enough to tackle one issue, but again there is something else which is creating problem for you, which is O of n. Okay. I mean the space complexity, right? And this is where JWT plays a big role. It sorts your problem out, and that's what we are going to see now. Now let's see how JWT works. Okay. So here you can see that active session database is totally gone. We don't store any active session here. Okay. And let's try to relate it with real life example. Let's say John and Manish are friend, and let's say, what do we name it? Let's say Sid. It's the birthday party of Sid. John and Manish are planning the birthday party of Sid. Okay. And they are all three all three are going together, and John and Manish have decided, uh, some specific keywords. Like let's say if the John says good night, that means the gift planning has been done. And if Manish says, let's say, good morning, that means all the party assets and invitations have been sent. Okay, so they are talking good night and good evening like that. But Sid, because he's unaware of these secret code words, so he has no idea what they're speaking about. To him, it seems like normal generic terms only. Okay, so the way these two people are interacting, because they have a key here, the key was this an algorithm that says that good night means this, good morning means this. Okay, in the same way JWT works. The way it works is you have a data which is a gibberish string which may look like this, and then you encrypt this data using a specific private key that stays just within the server, in this case in this UPI backend. Okay, so this can, this encrypted message can only be decrypted with this super secret key, okay, that is stored in the server. No one else can decrypt it. For others, it would be a gibberish string, a long gibberish string, okay. So let's say initial thing remains the same. John makes a request, UPI backend verifies in the database if the user exists, then fetches their details like email address, what are their roles. Let's say some have, uh, you know, mm, additional privileges depending administrator of account managers, so based on that they have the role stored, and then let's say they have their home address stored also, so and so on. Okay, so it fetches out this data and then it encrypts this data using this super secret key. Okay, and after encryption it looks like some very gibberish string, which is this. All right, and then this is returned as a token to the back to the John. Okay, and next time whenever John makes any API call, this token he supplies to the backend server for any other, let's say, get balance and so on. And since this token can only be decrypted by someone who has that super secret key, so every time John makes a request, it gets decrypted, and it checks if the decryption fails. That means either the token is invalid or it has been tempered. But if the decryption works fine, then it means it's a valid user, and then accordingly it returns the result. And this is how most of the modern web applications work using, JWT. This is much efficient than session-based storage because it takes away that all lookup thing and it saves you resource. This lookup with the key, with the help of decrypting and encrypting, it is a very fast process. So it optimizes in that end also, and that is why JWT is, better authentication system compared to session-based cookies. Now, since you know the theory, let's dive into, how these things can be worked out. And for this example, I'll be using Next.js. I hope that gave you a clear context over, session-based authentication versus JWT authentication. I hope you got an idea of how this happens, how encryption and decryption happens, and this is how most of the web applications currently work using JWT authentication, where you don't have a separate active cookie session where you have to do lookups or whatever. Okay, and this is very efficient. You just have a super secret encryption key and you use it to encrypt and decrypt the messages and transfer the payload. All right, so this was the overview of all this, and there are different types of, authentication. So let's say this is an open API which does not need any authentication, but if you wanted to have it, you pass it generally in header. You pass this as an authorization header, and it can be bearer, it can be basic, it can be also you have OAuth authentication, where I think you must be familiar with that. Whenever you log in via Google, it takes you to the Google page. From Google page, it asks you for the credentials, and from credentials it takes you back to, the Google page. So we will see those examples in this, and in case if you are interested into understanding how we code that, feel free to drop into the comments and I'll make another video on that as well. Okay, so if I tell you bearer, the way bearer token works is you tell that it is a bearer token, and then that big gibberish string that is generated and given by the, server when you log in, and then you can send request, and then it gives you it gives you that response accordingly. Okay, since this is an open API, so it's not asking me for any bearer token. Since it's an open server, so we don't have any authentication, so this putting this or not, it won't matter because it's an open API. Then you have something called basic authentication. So the way basic authentication works is that you have a base 64 encoded string, which is something like this. So let me quickly show you. So in case of basic authentication, you do it like this. You base 64 encode your email password or client ID secret or whatever. And generally this use case is used to generate a JWT, which is JSON Web Token. So when you send a request while logging in, you will find this kind of pattern being followed. And after login, you get the JWT, right? So only for login purpose, it is used like this. And if you have two-factor authentication, then it takes you another step. And after that, it gives you generated JWT. Okay. So base 64 encode, and then it sends you the response. All right. I'll just give you a walkthrough of these kind of authentication mechanisms. And if you are interested into digging deeper and understand how the code works, feel free to drop in the comments and we will have a separate video on that because it's a big topic in itself. Okay, so let me quickly show you some code here where, I just created a simple application and so that you are able to relate about all these authentication mechanism and how it works. I've created it using Next.js and Firebase for some backend database based operations and all that. So here we have some authentication use cases, and then we have databases where we have integrations, users and everything. So applications, there's a lot going on, so I don't want to go into that, but simply showing you basic things. So when you do a login, this follows the JWT authentication. First, it will send a request to Firebase, generate a JWT. The JWT will be generated using that base 64 thing that I talked to you about. So if I show you the login thing, this is a backend function. Yeah. So, the email password from there, it checks if they are valid, and then accordingly it gives you that, the token meaning the JSON Web Token that is going to be used for authorization requests. Okay. So there's a lot going on here. Don't be confused, but just get to know that this is how you can programmatically control it. And then in exchange of token, in the backend, I need to verify if that token is valid or not. So you can see I'm verifying that ID token, and if it is verified, then I'm collecting some user details, like the details about themselves. And then after collecting those details, I'm returning a response, login success, and everything with the status code that is required. Okay. So this is about login step. So once you log into the system, which takes some seconds, and then it fetches some application data that is created by that user, then you see that this is integrated with QuickBooks. So QuickBooks is an application which requires OAuth, and then after OAuth authentication is done, like the way you see logging in using Google and all that, once that is done, then it returns a authorized token. Okay. So when I click on this integrate with QuickBooks, you will see that there is some simple document which makes sure that okay, that user is aware of what exactly is happening and everything. And this is important because you are actually asking user to give access OAuth access of their QuickBooks account to perform operations on their behalf. So it's very important that your user should know. And once I click on accept and proceed, it redirects me to the QuickBooks App Store. It will wait, it will do all the OAuth thing, and you can see that I had this OAuth redirect and all the redirect URL and lot of state things happening, right? Just to be very sure that it is actually coming from QuickBooks and nowhere else. Now, since the process is done, everything is successful. So this is one final step just to be super sure. I'm asking them to enter their password, and once they enter their password here, um, I think it was this. Let me confirm. Okay, it says wrong, then this it must be this. And then once this process is done, then it logs in and then it will add the app, successfully added integration. And these integrations I'm creating here, so I'm creating some application QB integrations and so on, and accordingly I'm doing all these things. Okay. So this is whole end-to-end flow. You can see that there are a lot of states that is being shared in the OAuth application, and of course JWT is still straightforward, but understanding how the OAuth works and everything, that is pretty more complicated. Like you have redirect parameters and everything is very very important here. So of course, but again, it's not very very difficult as well. So this was to give you a context of how we can achieve these things in code also. And you can always ask me in comments if you want to understand a specific concept about this. We can have a video series on that. Otherwise, if you want to know, just a specific part of it, then also you can ask in the comments. And I hope you got a good context of all this and you learned something new. In case if you have still have any questions, feel free to bring it down in the comments. And until then, have a great day. Thank you very much.